Okay, hello. Um, I'm here with Zhichen, and we're going to talk about how to use GMSH um, to to draw a unstructured mesh, and that mesh will be used for simulating the coastal aquifer dynamics influenced by groundwater and seawater. And we used to draw a very good one, but the problem there is that the mesh sequence was not very good. So the name of the node is not in sequential order. As a result, what we call a bandwidth of the overall meshing is too large, and this will cause a expensive simulation effort, even the problem is the same. In terms of the band of the mesh, you probably can find it from a Sutra menu. This is Sutra 2.0 menu, which talks about the bandwidth of the matrix that you want to solve. So for example, you have a mesh looking like this with a number, with the node number, and the node number between these two is 15. And in terms of the same meshing, but if the bandwidth is small, the simulation time would much reduced as a result of the revised meshing. So this is explained well in 207. So we decided to remesh the system in a better way so that all the numbers are in sequence rather than hopping from one to the other. So this is the plan. So here we are trying to redo the meshing starting from scratch. So probably the best way is to just do a new. Yeah. Okay, let's do a new. And with just cascade meshing. And okay, use geo extension. This is just to say geometry kernel. It's probably
Either one is fine.
Either one's fine. Okay. Now, so we end up here. Then we basically need to define the nodes first. So it's literally a copy here. So should we start from this point to this point, or from, what do you think? From this point, probably. Yeah. Let's start from origin. So then the way how we're gonna do it is to use physical groups at point. Yeah.
Elementary entities.
Sorry, it's elementary entities at point. Okay. So then let's do 0, 0. Okay, let's move this one over here first. So this is going to be 0, 0, 0, and then thickness is 1, right? Okay, so let's do that. Oh, okay, so I need to put it in here. So I just put these numbers here. Right? Okay. It's a little bit tricky. So you try to put your cursors within this box so it doesn't move around. Because if I hop out, this number started changing. So the way is that you do this at. Okay, so the second one would be this one here. So the second one would be 5, 0, 0. So let's do 5, 5, 0, 0, at, yeah. And then the third one would be 30, 0, 0. 30, 0, 0. So let's do that. So 30, 0, 0. And the last one is 35, 0, 0. 35, 0, and 0. Add. Yes, okay. Now, let's move to the other layer. The second layer would be, this number would be boundary point. Okay, 0, 20, 0. So 0, 20, 0. Let's do add. Yeah. And then the second one would be 5, 20, 0. Yeah. 5, 20, 0. And let's do add. That point is there. Then this point would be 38. 18, 0. So 3, 0, 18, and 0. So let's add that point. And then finally we have 35, 18. 35, 18, 0. Let's do another add. And then it's the top. Point 11 is 0, 22. So it's 0, 22. Add. Next one is 5, 22. 5, 22. Add. And this one is 30, 22. 30, 22. Add. Oh, sorry. What are we gonna do?
I think you can undo the previous.
Okay, so what is the undo? Hold positions at point.
Or you can.
I can just.
Script.
Okay, yeah, I can do the add script later on. So if I made a mistake, so the very final one, we just keep going with that. 35, 22. Yeah, 35, 22. Yeah. So let's do 35, 22. Add. Okay. Then let's close this guy. And then according to this one, we need to use E to add Q to abort, right?
Yeah, EQ.
EQ.
Yeah.
So it's E and Q. That's what I typed. Now, we've already added those points, and then we would like to just have a review of it. So the way, how can you review it, is to go to mesh. Sorry, this is edit script. So if you click edit script, you will see this is actually a record of all the points that is being added. Remember that we have one that is wrongly put it in. We actually put in 2 that is wrong. So this 13 here is not necessary. So we can delete this one. And then we could also adjust this one as well. So that number is supposed to be, let's look at these, 30 and 22. So it's 30 and 22. Yeah, and then we save this. And then you could, so currently you see there are one extra point, another point that is wrongly placed. Nevertheless, if you just do the reload script, you will see everything goes back to the locations where it's supposed to be, right? Now let's do lines.
Yes.
All right. So the way how we're going to do lines, should we do this, all the horizontal lines first and then vertical lines? Probably, let's try that. Let's try that, and then if this one doesn't work, let's work on something else. Yeah?
Yeah.
Okay. So then it should be line.
Yeah.
Correct. So I just choose line, and then choose point to. Should it go all the way? No, it should go here. Right?
Right.
Yeah. And this one, and then keep going with these points to stitch them all together.
Yeah.
So we need to click a few times. So every line is formed by 2 clicks.
Yeah, I'm not sure whether it's better to do this from the right point to the left point, because when you define the plane here,
yeah,
it follows a certain direction.
But this one wouldn't. But if you do that, that means this line will be in this direction.
Yeah.
So how about if we're starting from this and C, and
Yeah,
then later on we figure out a better way.
Yeah.
Yeah. So now let's all of them do from left hand to the right hand, and see if this is able to give us a better meshing bandwidth. Okay, so this is vertical. Done. Okay, so now again, if you close this script and then do the edit script again, you will see all the lines is being down in the sequence. So remember, this one is directional. So line 1 is the point starting from 1 to 2, not from 2 to 1. So it is a directional line. The idea is that we would like to have the node number to be in the sequence so that the bandwidth is the minimum. Okay, so well, if that's the case, actually the other way of reducing the bandwidth is that you can start from the direction that has minimum number of grid first and then the longer one. So this is another trick you could do, but we just be aware of that. So at least it's better than the original condition where we first started with this trapezoid and then extruded. So in that way, the plane right in the middle is always been defined in the first place, and the meshing will be down in this section and later on to this rest of the section. And by doing this, you wouldn't be able to create a meshing that has minimum bandwidth, whereas this way might be, but we can look at how it could be further improved. So let's close this. Okay, so what is the next? So transfinite lines.
Next is to define a curve loop.
Okay, right. Yeah, so then the way how we do it is add, yeah. So it should be, it's not here. It should be transfinite, so that's curve, yeah. Physical
no.
groups, surface. No?
Well, I think you can add surface, point surface. If
Add
there's
point
no
surface.
curve loop.
Point surface.
Add plane surface.
Okay, plane surface here.
Yeah.
So then surface boundary. Okay, so this is the important part where we probably can order the sequence properly. So let's try to do a counterclockwise all the time so that everything starts from the origin. So that's the idea. So let's do, but then the tricky part is that this meshing will end up with meshing this section, this section, this section. It's section wise, isn't it?
Yes.
Yeah, so that is also a tricky part. But that's better than this because it's the plane that moves around. So it's just that this group will be meshed, then this group, then this group.
Yes.
Right? Whereas here it's just hopping around. So in that case, I'll start from here. So again, X at the beginning, so this point. So why these two lines is being selected all together? And these. And these. It's already been selected. Yeah. That should be fine?
Yeah, that
okay.
Should be fine.
So then EQ?
Yeah.
Yeah, E, so I click, I press the E and Q. Okay, so let's have a look. So if we're not sure whether we are on track or not, the best way is always edit the script. So we defined lines and we define a loop. So for the loop, we could first show all the line numbers. So window. So it should be window, right? No, options. Then it's geometry and line numbers. Mesh. General. No, I don't know. So it's visibility. 2D element, 1D elements. No. Labels.
2D element labels because the line is 2D.
Okay, so that means we need to choose 2D here. Wow, why?
That's mesh.
That's the mesh. We haven't started with the mesh. Okay, 2D element edges. Not yet. But can we show line numbers? Okay, so that is the 9. So that's point labels. Yeah, and then line labels. Curve labels.
Yeah. Yeah.
Okay, that's good. So let's go back to 1D. And yeah, so that's basically the idea. So as you can see, it starts from 1, 9, 1, 9, 12, 9, 4. And this is going to be -4. And -4 is because this is in the opposite direction as what 9, 4 is being specified, and -10. Right? And then we have the plane surface that is 1. Okay, so that's excellent, isn't it? It's very simple and intuitive.
Yeah.
And now let's just keep going with that. So I can zoom out by using the scroll on the mouse, and I also can use right click. If I press the right click and then hover around, I can shift the whole domain. So let's do that again. So choose plane surface and then click in again from X to Y. So X point, Y, Y, and then this one. So it's a kind of counterclockwise way. And then EQ, yeah? E, Q. And then let's do that again. So plane surface, 1, 2, 3, 4. EQ. Okay, now to be able to follow the our sequence, we again starting from this one and then go in this direction. So then we have plane surface, 1, 2, 3, 4. So usually the corner one is being selected by itself. So this time I'm not clicking the number 4 and see what happens. EQ. Then well, we can actually check. So edit script as before, and then we have 4, 13, negative. So 9, 4, 13, 7, and 11. So that's exactly what we are after. And then they have a plane surface as well. So you see that the curve loop is just being defined by when we're defining the plane surface there. So we just keep going. Plane surface. Maybe there is another thing we can do. 1, 2, 3, 4. Okay, I just press E here. I'm not pressing Q, so I'm trying to define another one here. 1, 2, 3, which is defined. I don't click the number 3, but I click number 4. And then I can do another E. Now, I think everything is meshed properly, so I quit this selection process and then press Q, so that when I go to edit script, yeah, well, you see that everything's fine. So usually in that case, once you move into a specific adding interface, you don't have to quit. So you can keep going as long as you press the E at the end of each definition.
Yes.
So that is a very clean version, which is very good. Now we need to do the transfinite, I guess.
Yes.
Yeah, okay. So before we do the transfinite, we try to make the numbers very small. So this region will be discretized by only 4 meshes, 4 cells. And this section, this big section will be maximum 9. How many we had before? So just checking the consistency. Well, it's here. So yeah, 6, only 6, yeah. Now, and the other one is only 4. And now, so should I do that?
Yeah.
Then transfinite, I think it's mesh.
Mesh define.
Mesh define. Transfinite.
Yes.
So curve
Yes.
first, and then click this.
Yes.
So 1.
Yeah, you better transfinite them together.
You mean I insert all of them?
No, just all the horizontal lines or all the vertical lines to make the.
Okay, so in that case, I should starting from X and Y. Yeah. So let's just undo the last. Should I do these, and these?
Yeah, you can do that.
You sure?
Yeah.
How about if I do this way? So everything is down from X, basically. 1, 2, 3, and I should do that one as well.
No. No. Because you transfinite them into two sections, but you transfinite the middle section into 3.
Right. Yeah. Okay. So then number of points would be 3, because if I put 4 cells to discretize this domain, the points at each line is going to be 3. And the parameter here 1 is basically, are you going to do it incrementally, or it's an average cut? So average cut would be 1, and then I can just say E. Yeah, E. Okay, so do E. Sorry, this E doesn't work here. So I put my cursors. I probably need to click here. I just clicked the GMSH interface.
I think you can close that window.
I close this window?
Yeah.
Okay, and then E. I think this is done. And we can keep going. It is done. 1, 2, 3. So this section I will have 4. So how can I allow this guy to come back? So E. No. I think somehow the transfinite.
You need to click Q because this time you are using different.
Okay, so let's try. I understand what you do. So 147. 147 is 3 points.
Yeah.
Using the progression 1, that's okay, which is average. This would be 4 instead. So I did it, but somehow it used the same parameter from the previous window. So I just use my hand to change it. So I save and then allow this to reload. Reload, so it reload script. So here. Now, can we actually see those points? No, not yet. No. Not yet. Okay. So probably we just keep going for the last one. So again, mesh define, transfinite, curve. Yeah. Okay. So that's 3 points. 1 parameter is 1. So 1, 2, and 3. Then I can do EQ. Yeah. Okay. Now let's do the vertical ones. So transfinite, curve. Then let's choose. So this one again has how many points? 1, 2, 3. So 3 points. 3 points. 1, 2, 3, and 4. Okay. Then EQ. Yeah. Now,
you also need to transfinite.
I need to transfinite the top plate. No, I don't have to though. Oh, because I need to transfinite that by 2, isn't it?
Yes.
Okay, that's very important. So even this line is being defined. If I don't put a transfinite by 2, then I wouldn't be able to discretize it. So I'm just trying to put it into the right direction. So I click Z because I somehow rotate the whole thing. So again, transfinite, curve. So this time only 2 points because our target is that this cell has only 1 cell. This region will be discretized by only 1 cell per row. So that's 2 and 1. So that will be down 1, 2. Right click and then shift, run 3 and 4. EQ. Now let's have a look. So click the original one and then edit script and see whether that is in the sequence. So 11, 13, 15, 17, that is basically the vertical small lines, and they are all just 2 points to discretize it, which is just the location at where the points are. That's done. Yeah. So okay. So then
Transfinite the surface.
I need to transfinite the surface. So in that case, it would be transfinite surface.
You can have a look at 2D mesh. If you don't, what happened if you don't? Yes, that's unstructured.
Yeah, and then I transfinite the surface. I click this one here.
Yes.
Okay. Yeah.
Click the dash line.
I did click the dash line, but it seems nothing. Oh, okay. So there we go.
Actually, maybe in 1D.
1D? Okay, that is easier. So should I just select E? Done. Yeah, and then I probably can have a look. But this is not what we're looking for.
You also need to recombine the surface. So this is like a structured triangle.
Okay, so then I need to just keep going with the way how I did for the rest, right?
Yeah.
So 1, and then click E.
Yeah.
And 1, E.
Yeah.
And same sequence, starting from X and then Y. E.
Yeah.
And 1, E. Yeah. And finally this section, E.
Yeah.
And then Q. Yeah?
Yeah.
Okay, then
you need to recombine.
Recombine?
Yeah.
And what I do?
Recombine all the.
So I select all of them.
Yeah.
Yeah, 1, 2, 3, 4, 5, and 6.
Yeah.
And Q. Yeah?
Yeah.
EQ. EQ.
Yeah.
Yeah, and
then click 2D.
Click 2D.
Yeah.
Wow, that looks very nice, right? I'll be interested to see how this section is being discretized. So in that case, I need to save files.
Yes.
We can't really put these numbers there. We probably wouldn't be able to. But can we put node numbers there? So let's see whether we can visualize the node numbers. Visualize. Probably points could go. Point labels could go. No, points are there. Point labels are not there. Curves can go. And then surface is 1, 2, 3, 4, 5, 6. That's beautiful. And then we look at mesh and visibility and 1D element labels.
Yes.
Well, that's just the way how it should be. Node labels. So 1, 2. So let's see how node labels is being done. 1, 2, 3, 4, 5, 6, 7, 8. See, this is actually not the best way to. It's still not in the sequence.
Yeah.
Yeah.
It doesn't decrease the that way.
So I think probably the best way would be that we choose. We basically know which number it will be, and then we can just adjust to that number. I think that would be a better way. But at least we pretty much can estimate the locations of each cell by doing that, which is still a very good exercise. Okay. 27. I think it will otherwise be very tricky to mesh that in this way anyway. Okay, so that is not too bad. So should we export and then see how the result looks like, and then we can mark how these numbers are there?
Yeah.
Now now we need to extract this mesh to a file so that PyTOUGH is able to read. And the way how we do that is that we click export, and once this interface popped out, you choose mesh -GMSH. That's the one that you're after. I have a template that's GMesh 2D version 2 ASK2 simple mesh. Let's say this would be sequence, because we basically try to improve the sequence of the mesh, which would be better than our previous attempt. So I can copy this file name so that I can use later on in our Python script. So I save it, and this is a little bit tricky. So to be able to extract the mesh, first of all, is that you need to click that's 2D. So let's do that before. Do that again. So before we do that, we really need to click 2D. So if it's 1D in this way, the information will not be in the file. So this is very critical. So you need to choose 2D so that all the information are shown on the screen, and then you do the export. And once you do that export, I said we need to save the file to be a type of mesh GMSH.msh and save it. and then so it's version 2 ask2, no clicks in these 2 points, and then click OK, and then the file is already being saved. So let's have a very quick view of what the file looks like. So that's the sequence, and then I just simply use a notepad to open it. Now have a look. So first is all the points 1, 2, 3, 4, 5, 8, 7. So these are the manually defined nodes. So in total are 32, and these are the numbers, and those are the generated nodes. And the 14 is basically 1300. So 1300 would be here. Yeah, and then 15 is here. 15 is here, and then 16 is there. 32.5, and then you have more grids in these points in a sequence. Well, the sequence is well organized. It's just that these nodes, these points are not in sequence with the later meshes, but this is expected anyway. Now, in terms of elements, so look at how element is being constructed. So the one that you particularly need to have a look is the ones that are called that's starting with number 3. So these are the node numbers. A 3 actually means it's an element, and then the element sequence would be, so this element is being defined by enclosing these points. So 1, 13, 29, 25. So 1 is here. 13 is here. 29 is here, and 25 is there. So that's basically this point. And then the 47 is 25, 29, 25, 29, 17, 5. So that's basically in this direction. Okay. And then 13, 2, 13, 2, 26, 29. Okay, so then it goes that way. So basically within this small region, we somehow meshed in a direction that goes bottom up and left to right. Yeah, okay. And then the next one, so 51 is 26. No, that's 214. So that's here. So that's the second one. So yes, this section is in this water. So in block-wise, it's in this direction. But within each big block, we started from bottom up. 20. So 26 is what? So from this to this first, and then that one to that one. So probably a better option here would be that we mesh, we transfinite vertical first and horizontal later. That could potentially give us this direction. Yeah, so that's the other option. Again, let's look at the script. Remember when we did the transfinite curves, we did all the horizontal verticals first. So 147, 147. So probably we did the horizontal first and the vertical later. So probably we can do vertical first and horizontal later, so that in the small blocks, your meshing could be starting from X and Y. So these are the possibility that we can further improve it, but we just give that idea. But in general, the idea is that you see that every block is being in a sequence from left to the right, from bottom to the top. Whereas within each block, the discretization is down from bottom up and then from left to right, which is a little bit contradictory, and that will end up with relatively large band matrix. But nevertheless, it serves for the purpose. Now, we've got this file, and then we need to allow GMSH to be able to read it. We've already done a very useful script in Python. So it's already been written, and you can download from PyTOUGH examples. So here I need to revise the name of that file, right? So GMSH 2D version 2 ask2 simple mesh sequence. and then I could try to restart kernel and run all cells. Restart. So 1, 2, 3, 4. No, hasn't started. So the star here means that it hasn't executed yet. So it's just on the process of rebooting. Now 1, 2, 3, 4, 5, 6, 7, 8. So 9. So this is the domain. It's already been read out. And A, they say that A is not defined is where the error comes from. So we can go to the line where the error is. Okay. Now, within this section, I define a small script, which is to look at the node that is on the leftmost. So if we go back here, so it would be this node and this node. But I think we probably have to. We need to put the mapping there first. Yes. Okay, so if that's the case, then I can file export and then save it as a what do you call that file? It's a vector file, and it has a SVG. Okay, SVG meshing regular. Yeah. Okay, so now I do the regular, and then I click OK. Then we can move this guy to our new. Wow, that's good. Okay. Okay, then I just drop in. This is not untitled, so I just save in the location where I don't know where it is. Okay, let's do another one. File, export. Yeah, it is. SVG. So try to do that again. Regular. .svg. I think I didn't get the extension name. That's it. Okay, so yeah, there you go. So I just drop it in. Well, that is too small, so I just get rid of all the boxes and I drop it in. Yeah, okay. Well, at least it's visible. I could also crop it to the right size. Okay, so and then we need to find out all the nodes and elements and things like in this way. So what can I do on this? So I can put this one here, right? And I can put the boxes in one of the boxes that we did before in this one. So this is PG. Let me just rearrange everything so that we have a better coordinate. So it's gonna be here. Okay, then because PyTOUGH does not export a file in this way, so it's usually ourselves to give an idea to define a very small mesh so that we know how the sequence will be looking like, and then we can make use of this one, and then just need to refine the number of lines in each so once we are happy with this, we can basically just do the edit script and then change the transfinite these numbers into the right numbers. That will make the mesh much more refined. So the simple mesh here is just to give us the overall sequences of everything. So in this case, then I will need to list all the elements here, right?
So what we did before is we check the mesh file.
Mesh file?
Yeah.
So I basically save it to the IMP file. That's what you say.
Yes.
Okay.
Yeah,
So in that case, I will need to find out a previous file that called IMP, right? Yeah.
Yeah.
So in the end, so this is a notebook. So I put it here, and then I just say flow regular. So this is the IMP file that I can read. So I can control enter to run this particular line. So once it's end up with 24, that means this line is executed. So then I can look at the SGD, and then you will be able to see flow regular file there. And this is actually the input for TOUGHREACT. So we move to basically element, and then we need to basically make these numbers, right? So 81, right? So where is 81? 1, 2, 5, and 5. So that's one. That's 81. Yeah.
Yeah.
81. Now AU1 should be this one, I think.
Yeah.
AU1. And AV1 is 3.75. So that's here, and 5.5. Yeah. It's 5. Yeah. AU1 and AV1.
AW1.
Okay. AW1. Yeah. So this is AV1. Okay, let's just keep going. So let's check whether this one is the next.
Yes, AX1.
So this is AX1. Sure. It's 3 and 4. Yes.
Yes.
9 and 4. Yes. So it's AX. Sorry. So this is AX1. AX1. So the next one would be AY1. The AZ1 would be around 17. X.
Yes, 17.
AZ1. And Y would be 4.5. 5.5.
Yeah.
Okay, so AZ1, and after that we have BA1, yeah?
Yeah.
Sorry. Okay, BA1, then it's BB1.
Yeah.
And BC1, yeah?
Yeah.
Okay, so just as a check, so BC1, the X would be around 28. 25, yeah, okay, that's good. And the Y would be around 15 something, yeah, okay. And then we have BD1, yeah? So BD is here. BD is 31, so yeah. BD1, BE1,
Yes.
BF1, and BG1, yes? And then now is BH here, so BH is, okay, BH, yeah. BH, BI, BJ, BK, BL, BM, and BN.
Yes.
Okay, that's beautiful. So that's exactly what we're after. Now, we wrote.
Probably put the index.
Okay, yeah. So I can do that here. We used to use this to show how this type of things is being organized. Well, it's not perfect. It doesn't show one like A and B, but it's just giving an idea that this one should be first. Maybe I can use this way. So this is 1, and this is 2 for this type of sequence. And then we can make a bigger one. So that's basically like kind of large blockwise mesh. So this is actually the number 2 because everything was with no, that's not a good idea. So I just move these here. So in large blockwise, it starts from X and then Y. But within the small blocks, it's starting from the Y and then X. That's just the idea. Now, we can do a calibration here. So the calibration is being done by checking so here is the groundwater section, and I try to find out the 2 blocks, small blocks, that is at the leftmost. So the name of this tool should be AT and AU. That's it. Yeah, AT and AU. Now, if I save, so the name of that is block name groundwater leftmost list, and then I'll be able to get AT and AUs. So that's good. Now we could also have a look at all the surface water cells and groundwater cells which were defined above. So that's the block name of the surface water list. So what I'm expecting is going to be BH, BI, BJ, BK, BLF, BM, and BN. So if I do that, BH, BI, BJ, BK, BL, BM, beautiful. And then groundwater list would be ATAV, sorry, I think the sequence would be ATAU, AV, AW.
Yes.
W and AXAY, AXAY, AZBA. Yeah, okay, so that's kind of sequence that we are expecting. And the tidal boundary is literally BG1. No, BN1 actually. So see whether these numbers are extracted properly. So everything looks fine. That's basically the end of tutorial, you reckon?
Yeah.
For now, we will have follow-up tutorials to show how to use GMSH, PyTOUGH, and TOUGHREACT to generate meshes and calculation cases to simulate fresh water and groundwater, fresh groundwater and seawater in exchange in the coastal aquifers. Thanks.